Good morning, everyone. My name is Althaf. I'm one of the leads at SRE in Grab. I'm sure pretty much most of you have used Grab here. And I know we have a lot of people who aren't from the region. So Grab is Southeast Asia's largest super app. We provide many services such as ride-hailing, food delivery, delivery of parcels, financial and payment services, right? When I joined Grab around 4.5 years ago, we were about 20 to 30 engineers, and now we have about 1,000 plus engineers across 6 R&D centers. So back in late 2015, Grab was growing, early 2015, late 2015, Grab was growing really fast, right? And if any of you all have worked in early stage startup, which is growing with like hockey stick growth, you know there's 100 things to do, and you don't have the people or you don't have the time to do all of them, right? And one of the first things in early stage startups that people don't focus on is operational stability, right? That's the thing that it's always focused on features. But around that time, we established the SRE team, and we realized that customers were coming to depend upon Grab as a platform, and we need to be up to serve our customers. And all the features were nothing if we couldn't be up. So we had to raise the bar in terms of operational excellence. And this actually there was a good point raised in one of yesterday's talks by Todd in actually one of the questions in the talk. We said, hey, if we have such a high availability requirement, if you're alerting on SLOs, then it's going to be too late because the system is already down, right? And our customers are affected. And the answer to that was, you need to design resilient systems, right? So that they don't go, they're resilient to outages. And that's what we needed to do. But what we needed also was to incentivize our developers to think in that mindset. And a lot of people talk about SRE being a mindset as well, and we needed a way to incultivate this mindset to our developers. And so we needed something really lightweight to do this, and proactive for our teams to work with without being reactive. So during this junction, once during a minor issue, my manager remarked at this point saying, is it possible that we have a small subset of our services that we could ensure that the main parts of our application always run, right? And we were just casually conversing about it, and we realized, this is actually not a bad idea, and it could be actually possible to do this. And we defined something called the critical path, right? We all know that a chain is as strong as its weakest link, right? And we were trying to define what that small chain could be. But first, we needed a definition of what the main part of our application was. So this was the definition that we came up with, right? It's quite wordy. Any impact on our systems that impacts the ability of a passenger to get a car, to get safely from point A to point B, right? You might see that there's no mention of food or parcels and so on because this was early days, and ride-hailing at that time was our primary focus. So at this point, we designed this is our critical path, right? And there's some nuances in this definition that I'll go to. And this is not also, one important part about this is that it's the ability to do it. It doesn't guarantee you a ride. It says, maybe it doesn't have all the bells and whistles of what you'd expect in the normal working version, but there's some alternative that you have to get a ride. And then we set 4 tiers. So we set critical, important, useful, and experimental. And we categorize services along these lines. I'll explain much later on why this was a bad idea. Again, we had some trade-offs when we made this definition, right? We were very ruthless in this definition. The first thing was, fares. There's no mention of fares at all in this definition, because we said, fares aren't that important, right? In the sense, yes, it's our revenue, but it's better we actually serve the customer to allow him to take a ride, right, rather than not serve the ride at all. However, the drivers won't be happy with not getting money off a ride, so we have to compensate them separately. Cashless payments. This might be surprising to those who come from Europe or the Americas, but cash is king here, right? Not maybe in Singapore, but in other regions that we operate in. And at that time, a majority of our rides used to happen on cash. So we said, why include a lot of our cashless payments in the critical path? We could exclude a lot of systems out of this critical path and just say, hey, you have an option to book with cash. Promotions, right? We used to be big on promotions. We still are, right? And that was one of the sticking factors why people would choose us. But we'd say, hey, if we could drop this system out of the critical path and still allow people to book a ride if they really wanted to, we could remove that system out of the critical path as well. And finally, we had that interesting clause called safely there, right? And this was to ensure that we had all our safety systems still working, right? This included our portals where when passengers or drivers called in, our call centers would be able to get the information that was required. This was very important, not so much in Singapore, but in the other regions where safety was a huge differentiating factor for Grab compared to the other vendors in the market. This final definition was signed off by our executive leadership. And it's really great to have something signed off by executive leadership because then everyone buys into it. So we now have a definition, and we have a theoretical list of services of what we think our critical path should be. But again, that's all theory. We need to test it out, and so that's what we started to do. We started to test these out on staging, very simplistic tests. All we did was take a non-critical service, completely shut it down, and test the critical workflow that we designed. And we checked whether it worked or not, right? If it didn't work, if it worked, great. It's not critical, move on to the next service. So we had about 80 services to test. We kept it, again, these tests were very simple because time was of the essence. We could have gone into more complex chaos testing with like testing, latency, different kinds of latency, different kinds of errors, but we had to keep it simple. And we found quite a lot of services that did not conform to our expectations. And I'll come to it later as well on how we fix some of these cases. And then we verified until we were happy with our staging tests. But then, as SREs, we have to test it on production as well, right? There's nothing, I think there was a mentioned talk yesterday, staging is never representative of what actually happens in production. And that was the only way that we would be confident in what we did. There was a bit of fun in getting approval to run these tests on production. But one thing that we are lucky with is we operate only in Southeast Asia. So we have a cyclic behavior of our passengers because there are very little rides happening late at night. So we have a great opportunity to do some tests at this time without disrupting a lot of customers. So we did prep our local teams. We communicated to our drivers and passengers in advance to tell them, hey, there might be a small period of disruption during a few hours, and we ran the tests. We tested around 50 services across 8 hours, across 2 nights, and it was a great success. Out of the 80 services, only 1 service misbehaved, and it was just like a display issue more than anything, and it was fixed like the next day. We actually had some side benefits of running these tests as well, right? In preparation for these tests, a lot of service teams realized that, hey, they need to figure out what's going on in production when these tests are running, and they realize, oh, I don't have good dashboarding, right? And they fixed all their dashboards, right? We also found, for those who didn't, when some services were brought down, and then we realized, hey, why is there no paging alert when the service is down? They went and fixed that up as well. So we now have a list of services. How did we fix them? I think this is the part that where I'm going to share what we did in Grab, and you can take away from it. And this is also relevant to the engineers because most of this is what we SREs would think as, oh yeah, that's common, that's basic. But as engineers, it's not always at their forefront. It's not always at top of mind, right? They are always focused on the correctness of the feature, how it looks, how it flows, and not always on what the gracefully degraded experience looks like. Another key part that we had to do was to always involve our product teams in this decision, right? Because the experience still had to be cohesive, right? You don't want always make every decision like the engineers making these decisions in isolation. You want an overall flow even to a degraded experience. So the first thing that we did was started using circuit breakers to fail fast, right? I'm not going to go deep into circuit breakers. We used Hystrix Go for our Golang, the great port of the Netflix Hystrix library, and we used a similar pattern in Ruby using the stoplight gem. So caching, right? The first thing was we started becoming a lot more aggressive about caching. Caching is a double-edged sword, as we all know, but one thing that we really benefited from was caching data that was very static, right? But was still served by core systems like our geofences, like define the boundaries of the cities that we operate in. The city data, we would add cities, but we would rarely change any city's data, right? Similar for countries that we operated in. And the one that most frequently changed was vehicle type metadata, but even that was something that we could keep cache for quite some time. And one thing that we did was we would cache the data on startup. So every time a service starts up, any instance of it, it would load the data load this data and cache it into a Redis. We would have a TTL to make sure that we don't have a thundering herd problem if all the services restarted at the same time. And this eliminated a ton of services out of the critical path immediately. All of these core data that we would consider core, you can never go down, suddenly was out of the critical path. Some services also took an additional step of additionally caching this in local memory, just in case the Redis was inaccessible for some time as well. In some cases, we actually utilize mobile caching. So one of the things that we do is, if you go use a ride-hailing app, you want to set up pickup and a drop-off location, right? And for most people, you have a very few pickup and drop-off locations that you use all the time, right? Home, office, gym, your favorite restaurant, we started caching this data in, right? And even if our POI system was inaccessible for a short period of time, the app would still show these frequently used POIs, still allowing passengers to book rides. And on our driver app, we did a similar thing as well, where we have a concept of active vehicle types. So a driver could be active on multiple vehicle types at the same time. So for example, a driver who drives a 6-seater vehicle could choose to take 6-seater jobs as well as 4-seater jobs, right? If he or she wanted to. And they would be constantly refreshed when they log in and a periodic time. But if for whatever reason those requests failed, we just fall back to the cached version. Sticking to our POI system, right? One of the things that we did is we had our own internal routing provider, but we started using third-party multi-routing providers as well, right? And we did something differently here, although it's titled Fallback. We didn't always rely on them as a fallback. We would constantly send traffic to them, just because we didn't want any surprises when we actually fall back to it and it didn't work for whatever reason, because they had changed the data format or something like that. So we were always sending 1% of our traffic to these third-party providers and constantly mixing the results in with our internal routing provider. And we also did, in case all of the routing providers fail for some reason, potentially maybe a network issue, we would fall back to straight line distance, right? And yes, this would be a terrible experience in terms of the accuracy of the fares that were generated or the accuracy of the ETA that was generated, but it's still better than nothing. As long as the fare was lower than the customer would be happy, right? And as long as our passengers are happy, we could always deal with the drivers later on, right? We could always tell the drivers, hey, we know that the fares are low at the moment, but we'll compensate you separately, or we'll fix that later. And our passengers are happy, oh, it's 50% off, I'm going to take a ride. We actually had problems sometimes when our fares had problems, and we were having a surge in demand, Finally, retries and queues, right? So we didn't have a good strategy at this point, and this is something that we designed based on this critical path exercise where we didn't have a good queuing and retry strategy in Grab at that point. And we had really good use cases for this, for what we call commission deduction. So the commission is what we take from the fare, the percentage the cut that Grab takes, right? And this is done on the completion of the booking. However, it doesn't have to happen at the completion of the booking, right? If it happens an hour later, it's not the end of the world. It might be a bit surprising to the driver if it happens 2 days later, but an hour later or 2 hours later is not too bad. And so we had services build the queuing system to retry. Similarly, for allocation of what we call reward points, which is points that the passenger gets for taking bookings or spending money on payments. These points could be rewarded 15 minutes later, 30 minutes later. They didn't have to be instantaneous. A lot of the assumptions that developers made were, this will always work. And so if it doesn't work the first time, then it just fails, and that's a worse experience. And then finally, sometimes it's okay to fail, right? We had this interesting problem once where we caught on staging, which is at the end of the ride, we would pop up a screen to rate your driver. And that ended up being a hard blocking call. The app would not allow you to proceed if you couldn't rate your driver, which is, if anyone thinks about it, it's I want to take a ride, but you're forcing me to rate a driver, and I can't, and now I'm stuck, right? Which is a terrible experience. So it's okay to fail in the sense if that call fails at the moment, just dismiss it, go let the passenger do whatever else he wants to do, and then let them, if they want to, they could rate the driver from the history page, right? Similarly, ETA, we show an ETA, when someone's coming to pick you up, and this ETA, when it failed, would show an error pop up every single time, because the ETA gets refreshed like every few seconds. Again, this is why the product managers are important, because they would come and say like, hey, that's a terrible experience when they see it, right? And they don't always see this. So all of these techniques might seem common for us and easy to understand for us, but it's not always, especially when there's a lot of pressure on the engineers, the product managers, and everyone's looking at them for features. It's not always top of mind, right? And what this effort made us do is make them consider and realize that, hey, this is something that should be part of the design itself. It should be part of the feature itself. And then product managers would all design for these unhappy cases in the product spec itself instead of waiting till we brought it up. Right? It was a gradual mindset change that we were able to manage. There were some additional benefits of this exercise as well and this project. The critical services weren't just the ones to benefit. As these techniques and concepts matured in the organization, people started implementing it in non-critical services as well, right? And that was just a good win. Similarly, our tooling and frameworks started incorporating some of these things, such that developers don't even have to do it. It's automatically there by default. We also did some changes to our deployment pipeline, such that critical services were put on a separate queue compared to our non-critical services. So if you're a non-critical service, deploy in parallel, whatever, no issues. If you're critical, we just serialized you, such that there's no two critical services deploying at the same time. And our critical path was around 12 services, so it was fine, right? It wasn't like we had 100 critical services. Similarly, we adjusted our tooling to highlight changes that were done on critical services, because if there was a problem that was really big, as usual, it would be something that was changed on a critical service, and this would just filter out and tell you, hey, was there a recent deployment on a critical service? Was there a recent config change, and so on. And then finally, I think the biggest improvement that we got was architectural changes, right? Developers started realizing that there's a lot more rigor put on critical services and the review of critical services, that they didn't want this on their non-critical parts. And so they started extracting out the non-critical parts of the system into their own services so that they could move fast there and keep critical services small and contained, which was exactly what we wanted, right? Because then they changed less frequently, which means they're easy to test, they're easy to think about and validate, and it allows the flexibility and freedom for non-critical services to move much faster. But there are some things that I wish we could have done differently if we were to go back and do this all over again, right? The first thing is naming. The word critical, although critical path makes sense, the word critical as a tier is very overloaded, and people use it and have very different nuanced meanings about it. And it's very awkward to go tell someone, hey, the payment system is not critical, and they look at you like, what? And it just muddies the water, and I wish we could have named it something differently. Tiers might have made sense. I felt the word critical kind of confused people. The second thing was, remember I said we had 4 tiers: critical, important, experimental, useful, experimental. But I never talked about other tiers because in reality we didn't actually use them, right? Pretty much we only concerned ourselves with critical and non-critical services, so we could have just limited it up to being, tier 1 and everything else. The third thing was automation. About the testing that we did all this testing manually, which was very laborious, and therefore we could only do these tests like every quarter or every half of the year, because it's just expensive, like in terms of manual effort to do. If we had built the automation earlier, we could have done these tests a lot more frequently. This led us always to worry about what if a service has accidentally taken a non-critical critical dependency on a non-critical service, right? This would only get exposed either in the test or in an incident, right? And there was always this at the back of the mind. There's a worry, and if we had the automation, we could have validated this a lot faster. Finally, I think we could. So similar to that, we could have kept track of new services because we didn't have the tooling around that. Services would start off as experimental and then gradually creep up the tier and then become critical without anyone knowing, without anyone being informed. And then finally, I think working closely with the mobile devs. So this effort started very much as the backend service centric, like with the backend service focus. But since we control the client, and since most of us, it's on the mobile app, we didn't really validate the behavior sometimes on the mobile application itself, just validating the backend behavior. And what would happen would be that there would be different behaviors between our, like say, our Android app and our iOS app, right? And this led to different experiences, or the way that they use the APIs was different. We should have worked closely with them to make sure that the whole flow was quite coherent. So these are things that I felt that if we could go back, we would have done differently. So what can you take away from this, right? We found this exercise and project, we still do it to this day, quite useful when we were growing rapidly to make sure that everyone's really thinking about graceful degradation, right? If everyone's already thinking that in your company, then you don't need this, right? That's great. But not all engineers do. The second part we found useful about this was it became training material, right? We were able to showcase, like, hey, this is what a service did to get itself out of the critical path. Or this is what, if you didn't do this, you would be critical. So if you were to do something like this, the first thing that you'd want to do is define your critical path and probably get your executive leadership to sign off on it. So make sure that they're aligned on the definition. The second thing is you're testing your assumptions. So I would say if you could get it to testing once a month, that would be good. If you can get it to a lower cadence than that, that would be even better. And then every 6 months or so, you should evaluate your definition of the critical path to make sure that it's still aligned with the business goals, right? As I said, our original critical path definition had no mention of food or payments. They are now in our current definition. So thank you. Oops. I'm not much on social media, so I'm an old school email kind of guy. You can email me on that. We're also hiring. If you're interested, you can come talk to me afterwards or go to the website. And do I have any time for questions, I think? Maybe a few minutes. If anyone has any questions. Yeah, can you use the mic?
Yeah, so you mentioned that you did a first test in production. After that, how often do you keep doing this kind of real-life tests in production?
Yeah. So we were doing tests every 4 to 6 months, which, as I said, is probably too long in between tests. Ideally, we would have liked to get it to at least once a month. If you're going to get it even faster, that would be even better. But we were originally doing it 4 to 6 months. Yeah.
Hi there. I'm just wondering about the getting developer buy-in into your, say, using Hystrix and, basically building up the capacity within those development teams to think about the, I guess, non-application features, more of the architecture.
So in the beginning, it was hard. So we had to go spend time with the SREs had to go spend individual time with the development teams to go and figure out. So we wrote out what we believed would be the ideal critical path. And then we sort of challenged the developers to tell us, no, it cannot be this. And so a lot of developers didn't want to do the work to say, no, it couldn't be this. And they're like, okay, we'll work with you all to get that rolling. The main thing here is that the developers are good intent, like they have good intentions. It's just that we needed to show them, hey, this is actually possible.
I guess the second question would be around that. How do you get that prioritized or in the backlog of the work that they do?
Sure. So that's where the executive buy-in worked really well, right? I can't remember the exact numbers, but we were estimated that before our staging tests, we estimated that we had about 22 critical services, and we said we wanted to bring that down to 15, right? That was our theoretical version of it. And that we put as our OKR, our company-wide tech OKR. So that automatically gets, you can prioritize work because you say you want to meet your OKRs.
So you mentioned that one of the things that you hoped that we could do better was that you work closely with mobile developers, and also to ensure consistency in terms of services not creeping up to become critical. So how do you guys do that now today? I mean, do you have like a community built within the company itself? I mean, how do you ensure consistency that if a new developer comes on board, they know, okay, this is the service that I should use, or this is the API I should call, and I should not be using like 15 different granular APIs to make one single call, or just one giant API to make one call, and it just slows down your entire app.
Yeah, I think can be answered in two ways. So part of the reason where I said it didn't work out that way in terms of working with mobile developers was sort of how our organization was structured at that point. Mobile developers were sort of clumped as mobile developers, and backend developers were clumped as backend developers. Now we have a sort of vertical structure where in the teams you have a mix of both mobile and backend developers working on like team product focus. So automatically, because there's a product focus, they work together closely. So we've got that interaction fixed out now, just by organizational structure changes. In terms of inconsistencies, that still happens though, like because if the communication doesn't happen, mobile developers, we don't go validate every single thing. If it happens and we detect it, we fix it later. How can we prevent it? Communication, but sometimes it doesn't always work. All right, thank you very much.